Welcome to our second lesson on quadratic functions. In the previous lesson, we dealt with the turning point form of the equation of a quadratic function. Now, in this lesson, we will take a look at the standard form of the equation of a quadratic function. Okay. Now, the standard form of the equation of a quadratic function is an equation of the form y is equal to ax squared plus bx plus c, where a indicates whether the graph is concave up or concave down. Okay. Now, if a is a negative value, the graph will be concave up, and the turning point of this graph will occur at the minimum point. Now, if a is a negative value, the graph will be concave down, and the turning point of this graph will occur at the maximum point. Now, b and a are used to determine the graph's axis of symmetry in the formula x is equal to negative b over 2a. Okay, now this gives us our equation of the axis of symmetry. Now, to find the coordinates of the turning point, we take the value of the axis of symmetry as the x coordinate and substitute back into the equation of the graph for x to find the y coordinate of the turning point. C in the equation is the y-intercept, okay, which is the constant. Now, we are going to do an exercise on how to plot the graph of a quadratic function when given the equation of a function in standard form. Okay. In this exercise, we are required to sketch the graph of f of x is equal to x squared plus 7x plus 12. And next, we are required to write down the domain and range of the graph. Okay. Now, when sketching a graph, the first step is to identify the graph from the given equation. Our given equation is f of x is equal to x squared plus 7x plus 12. Okay. Now, this is an equation of the form y is equal to ax squared plus bx plus c. Okay, which is the standard form of the equation of a quadratic function. Now, in our case, a is equal to 1, which is a positive value. Therefore, the graph must be concave up like this, with the turning point of the graph occurring at the minimum point. Now, the second step is to calculate the x and y intercepts. Okay. Now, starting with the x-intercept, these occur when f of x or y is equal to 0, since anywhere along the x-axis y is equal to 0. Now, our f of x is given by x squared plus 7x plus 12, and this is equal to 0. Now, factorizing this equation, we get x plus 3, x plus 4, giving us a 0. Now, solving for x, we get x is equal to a negative 3, or x is equal to a negative 4. Okay. Now, the coordinates of the intercept with the x-axis are negative 3 and 0 and negative 4 and 0. Okay. Now, the next thing to determine is the y-intercept. Okay. We only have one y-intercept, and this is given by the constant in the equation. Okay. The graph will cut the y-axis at 12. Therefore, the y-coordinate of the y-intercept is 12, and since anywhere along the y-axis x is equal to 0, therefore the x-coordinate must be 0. Okay. Now, the coordinate of the y-intercept are 0 and 12. Okay. The next thing to do is to write the equation of the axis of symmetry. Okay. Now, we determine the equation of the axis of symmetry using the formula x is equal to minus b over 2a, and in our case b is 7, therefore this is negative 7 over 2, and a is 1. Now this is equal to negative 3,5. Okay, that is the x value of the axis of symmetry. Now the next step is to calculate the coordinates of the turning point of the graph. Now the turning points are given by negative b over 2a being the x coordinate of the turning point, and f of negative b over 2a being the y coordinate of the turning point. Okay, now this is the value of the equation of the axis of symmetry, and we substitute that back into the equation to get the y coordinate. Okay, now y is equal to f of negative 3,5. Okay, now this is equal to negative 3,5 squared plus 7 multiplied by negative 3,5 plus 12. And plugging this into your calculator, you should get negative 1 over 4. Therefore, the coordinates of the turning point are negative 3,5 and negative 0,25, or negative 7 over 2 and negative 1 over 4. Okay. Now the next thing to do is to plot the points on the set of axes. This is our y-axis and this is our x-axis. Okay. Now let's say this is our negative 4 on the x-axis, and let's say this is our negative 3 on the x-axis, and this must be our negative 3,5 on the x-axis. Okay. Now the turning point is given by negative 3,5 and negative 0,25. So if we let this be negative 0,25 or negative 1 over 4, this becomes our turning point, and its coordinates are negative 3,5 and negative 0,25. Okay. Now the y-intercept occurs at 12 on the y-axis. Okay, so we just indicate this is 12. Okay. Now the next thing that we do is to join our points using freehand smoothly. Okay, the graph must intercept the y-axis at 12. Okay, now the left hand side we do the same. Okay, now this is the graph of f of x is equal to x squared plus 7x plus 12. Okay, now the next thing to do is to write down the domain and range of the graph. Okay, we will write the domain here and we will write the range here. Now the domain are the x values of the graph. As you can see, the x values stretch from negative infinity to positive infinity. Therefore x must be an element of real numbers. And the range, the graph starts from negative to 0,25 all the way up to positive infinity. Therefore the range y is greater or equal to negative 0,25. Okay. We have covered all there is to know about the two forms of the equation of a quadratic function. Now we will show that these two forms are equivalent and how you can convert from one form of the equation to to another. Okay, now if you start with the turning point form of the equation of a quadratic function, you can expand this equation in order to get the standard form of the equation of a quadratic function. And if you have the standard form of the equation of a quadratic function, you can complete the square in order to get the turning point form of the equation. Okay? Now what we are going to do is to do some exercises and show how you can do this. Okay? The first question in the exercise says f of x is equal to x minus 3 squared minus 9 is an equation of a quadratic function written in the turning point form, and we are required to write down the equation of f in standard form. Okay, we are given the equation of f of x is equal to x minus 3 squared minus 9, okay, which is the turning point form of the equation of a quadratic function. Now to move from the turning point form of an equation of a quadratic function to the standard form of the equation, we expand the turning point form. Okay, now f of x can be written as f of x is equal to x minus 3 squared is same as x minus 3 multiplied by x minus 3 minus 9. Okay, now this gives us x multiplied by x, giving us x squared minus 6x plus 9. Okay, and we also have a negative 9 here. Therefore, this is equal to x squared minus 6x. 9 minus 9 is just a 0. Okay, so the standard form of this equation is x squared minus 6x. Okay, now remember there is a 0 here that we just don't write. Okay, now this 0 is the constant of this equation. Therefore, the graph of f must cut the y-axis at 0, which means that the graph goes through the origin. Okay, now let us look at another example. The second question says f of x is equal to x squared plus 4x plus 3 is an equation of a quadratic function written in standard form, and we are required to write down the equation of f in turning point form. Now the given equation of f in standard form is f of x is equal to x squared plus 4x plus 3. Okay, now to convert this equation into its equivalent turning point form, we need to complete the square. Okay, now this is how we are going to complete our square. We will rewrite this equation as x plus the coefficient of x divided by 2. Okay, this is squared minus the coefficient of x divided by 2 squared plus 3. Okay, now this is equal to x plus 4 divided by 2 is 2. Okay, squared minus 4 divided by 2 squared is a negative 4 plus 3. Okay, now this gives us x plus 2 squared, negative 4 plus 3 gives us a negative 1. Okay, and this is the turning point form of the equation of f. Okay, now this method will only work if the coefficient of x squared is a positive 1. We will see in the next question how to handle coefficients which are not a positive 1. Okay, so let us move on to the next question, which is question 3. The third question says, given the equation f of x is equal to a negative x squared plus 4x plus 5, part A, write the equation of f in the form y is equal to a, open bracket, x plus p, close bracket, squared, plus q, where a, p, and q are constants. Okay, that is part A. Now, the equation of f in standard form is given as f of x is equal to negative x squared plus 4x plus 5. Okay. Now to turn this equation into its equivalent turning point form of the equation of a quadratic function, we will have to complete the square. Now our method only works when the coefficient of x squared is a positive 1, okay? Now in this case, the coefficient of x squared is a negative 1. So before we can use our method, we will have to manipulate the given equation by factoring out a negative 1 on the right hand side of the equal sign, okay? So we will rewrite f of x as f of x is equal to negative factored out. Now the coefficient of x squared is a positive 1. So x squared minus 4x minus 5, okay? Now we can complete the square for the contents in the brackets, okay? So we will rewrite this as f of x is equal to negative open bracket. So the contents in the brackets can be written as x plus the coefficient of x divided by 2, that will be negative 4 divided by 2. This is between brackets and it is squared. Then we subtract the coefficient of x divided by 2 squared, okay? This is squared minus 5, okay? Now this is equal to a negative of x minus 4 over 2 is x minus 2. This is squared minus negative 4 divided by 2. This is a negative 2. If you square it, you get a positive 4. And multiply by a negative 1, you get a negative 4 minus 5, okay? Now this is x minus 2 squared, negative 4 minus 5, this is a negative 9, okay? Now we will multiply through by this negative 1, okay? This will be negative of x minus 2 squared plus a 9, okay? This is the equation of f in the turning point form, okay? Now part B says, hence write the equation of the axis of symmetry of the graph defined by this equation and the coordinates of the turning point, okay? That is part B. Now the equation of the axis of symmetry can be obtained by equating x minus 2 to 0 and solving for x. So x minus 2 is equal to 0. Solving for x by sending negative 2 to the right hand side, x is equal to a positive 2, is the equation of the axis of symmetry of the graph of f, okay? Now the turning point is given by the value of the axis of symmetry is the x coordinate, okay? And the y coordinate is this positive 9, okay? So the turning point coordinates are 2 and 9, okay? Now part C says, is the graph concave up or concave down, okay? Now in our graph in our equation, A is equal to a negative 1, okay? Which is a negative value, therefore the graph must be concave down and the turning point of this graph must occur at the maximum point, okay? Now let us try another similar problem, which is question 4. We are now on the last question under the exercise, and it says, given f of x is equal to negative 5x squared plus 4x plus 1, part A, write the equation of f in the form y is equal to a open bracket x plus p close bracket squared plus q, where a, p, and q are constants, okay? That is part A. Now the equation of f in standard form is given as f of x is equal to negative 5x squared plus 4x plus 1, okay? Again, the coefficient of x squared in this equation is not a positive 1. It is a negative 5 in our case, okay? Now, before we can complete the square, we are going to manipulate the equation so that the coefficient of x squared becomes a positive 1. Okay. Now to do this, we will factor out a negative 5 on the right hand side of the equation, so that f of x becomes negative 5 open bracket x squared minus 4 over 5 x minus 1 over 5. Okay. Now we can complete the square for the expression in the brackets. Okay, negative 5. Now completing the square, we can rewrite the expression in the brackets as x minus the coefficient of x divided by 2 becomes minus 2 over 5. Okay, this is squared, minus the coefficient of x divided by 2, this is negative 2 over 5, sorry. And this is squared, minus 1 over 5. Okay, now this is equal to a negative 5 x minus 2 over 5 squared. Okay, this is minus 2 over 5 squared, that is a 4 over 25, minus 1 over 5. Okay, giving us negative 5 open bracket x minus 2 over 5 squared, and this is negative 9 over 25. Okay, now we are going to multiply through by negative 5, and this is equal to negative 5 x minus 2 over 5 all squared plus 9, since this is a negative 5 over 5. Okay, now part B, hence write the equation of the axis of symmetry of the graph defined by this equation and the coordinates of the turning point. Okay, now the axis of symmetry can be obtained by equating this to 0. So x minus 2 over 5 is equal to 0, and solving for x is equal to 2 over 5. And this is the equation of the axis of symmetry. Okay, now the turning point of the graph is given by 2 over 5 and 9 over 5. Okay, where 2 over 5 is the value of the equation of the axis of symmetry and 9 over 5 is Q. Okay, now part C says, is the graph concave up or down? Provide reasoning for your answer. Okay, now the coefficient here A is equal to a negative 5, therefore the graph must be concave down. Okay, with the turning point occurring at the maximum point or the highest point on the graph. Okay, being able to convert between the standard form and the turning point form can be very useful sometimes. Please try these examples on your own again and make sure you understand how it is done. We will conclude quadratic functions in the next lesson. Thank you for watching. I hope to see you again in the next lesson.